Consider the quadratic function y equals x squared minus 2x minus 3. Use the table function of the graphing calculator to make a table of values for the domain of all integers from -3 to 5. Put the points on the coordinate graph below. Connect the points with a smooth U shape called a parabola. Okay? So we want to go our x values from -3 to 5. Putting this into the calculator gives us our y values. 12, 5, 0, -3, 4, -4, -3, 0, 5, and 12. Then we graph those points. -3, 12, it's going to be up off the graph. -2, 5. It's off the graph, but not too far that we can't go ahead and draw it, right? -1, 0, 0, -3, 1, -4, 2, -3, 3, 0, 4, 5, and 5, 12. Besides the fact that it tells us I can connect them, how do I know I can connect them? It's giving me an equation, right? Okay. The points where the graph turns, the point where the graph turns is called the vertex. Write the coordinates of the vertex of this problem. 1, -4. Anybody agree with him? Tell me why you agree with him. It's where the parabola turns. Very good. Okay. 1, -4. In this case, do you think this would be called a minimum or a maximum? Why is this called a minimum? Lowest point, on the graph. Is there ever any time that a parabola would then ever have a maximum? If it's like reflected? If it's a negative x squared term? Yes? Okay. The graph is symmetrical to a vertical line through the vertex. Draw a dotted line on the graph representing this line. A vertical line through the vertex. I see some of you using different colors to do this. That's great. I am. What's the equation of that line? X equals 1. Okay? I'm okay with that. What do you think is a really popular incorrect answer? Just 1. But see, that's not a problem with you guys because we just got done working on our project, and if I needed a vertical line on my graph, I couldn't just write 1, could I? Okay, had to be x equals 1 or y equals 1, some sort of variable to know that that's what it looks like when I graphed it. Okay, this equation is for the line called the axis of symmetry. Sometimes we just call it the line of symmetry. Okay. What point is the y-intercept? Y-intercept crosses the y-axis, right? 0, -3. Where does this number appear in the original function? Where does it appear in the original function? It says y equals x squared minus 2x minus 3. It's right there, isn't it? You could just write what I wrote. What point has the same y coordinate but lies on the other side of the axis of symmetry? Same y coordinate but other side of the axis of symmetry. Yeah, 2, -3, right? Excuse me. So That's another name for that point is a point symmetric to the y-intercept. Any idea why that would be a point symmetric to the y-intercept? If I folded over the line, it would be on top of each other. It's the same distance from the line of symmetry, right? Any of those will work. Does that make sense to everyone? Are you lying? Okay, good. There are two x-intercepts. What are their coordinates? How do you know that? That's where it crosses the x-axis. Okay? So -1, 0 and 3, 0. So the good part about your answer is the fact that you told me in points. Okay? Common incorrect answer is -1 and 3. Well, I agree that those are the x-coordinates of the points of the x-intercepts. X-intercepts are at the end of the day a point, right? So we have to write them as such. Find the factors of this expression. Leading coefficient is 1, so multiplies to be -3, adds to be -2. Very good. What is that? X plus 1, x minus 3. Okay. How do the factors compare to the x-intercepts? Solving each factor equal to 0 gives us what? The intercepts. Right? If I set this factor equal to 0, x plus 1 equals 0, solve for x. Subtract 1 from both sides, x equal -1. Doesn't the x value of this x coordinate be -1? I just said be -1. You know what I meant. Thank you very much. How can the x-intercepts be used to determine the factors of a quadratic equation? Anybody? If I had an x-intercept of, let's say, 4, 0, and -5, 0, what would be my factors of this particular function? X minus 4 and x plus 5. What if I had x minus 3 and x minus 2? What would be my factors? Okay, or it looks like I did it opposite. These are the factors. What are the intercepts? 3, 0 and 2, 0. Can you go back and forth from one to the other? Good. Write a generalized rule for finding a quadratic equation. You want to see what they wrote? That's what they wrote. X minus the first solution times x minus the second solution. Does that make sense to you? Good. How does the graph show that the quadratic is a function? How do we tell if something's a function? What? That means it's continuous. It doesn't make it a function. X's don't repeat. Or, what's the other thing we used to say when we're trying to figure out if something's a function or not? Passes the vertical line test. Excellent. Why is this function called quadratic? I mean, anybody have the initiative to just call it like Bob or something? Or did you automatically call it a quadratic? What made it a quadratic and not a Bob or a Frank or a linear? What? Yeah. X squared. The 2 is the highest, what? Exponent. Any questions? We good so far? Okay, then let's talk about some general quadratics information. Okay, some of the stuff you've seen before. So they just put it in a big chart on the front of the page. Did I give you this? Okay, here. Somebody? 2 people? Thank you. At the very top, it gives you both the vertex form and the general form. So look back at those if you need it, but you have seen both of these before, yes? Okay. In the middle of the page is a comparison of characteristics. Depending on whether you have standard form or vertex form, it shows you how to get each one of these characteristics on the side. Notice some of them are much easier to find depending on what form you have. Notice that you know that the vertex is at HK, and if you have vertex form, look how easy it is to find the vertex. If you're trying to find the vertex of standard form, it's a little bit more involved. You have to use that formula right there, which says negative b over 2a. But all negative b over 2a gets you is the x-coordinate of the vertex. Yes? Okay? And then you actually have to plug that value into the equation for x to find the y value of the vertex. That may not make sense right now. Hopefully it does. Let me know, yes or no. If not, I think it will in just a moment when we get to some sample problems. Fair enough? Okay? But here's the deal. In both cases, once we know the vertex, we also know the axis of symmetry. Because if I know the vertex is HK, and I know that the axis of symmetry is x equal h, it's whatever the x-coordinate of the vertex is, right? We figured that out on this page, right? Whatever the x-coordinate of the vertex is, isn't that the axis of symmetry? Yes? Okay. So, but that works for vertex form or standard form. It doesn't matter how you get the vertex, but once you know it, you also know the axis of symmetry. The y-intercept, which one is easier to tell? Standard form or vertex form? Standard form, very clear. 0c. C is given in the equation, right? In vertex form, we know x is 0. We just have to substitute in a 0 for x and solve for the y. Okay? Points symmetric to y-intercept and the x-intercepts, we'll talk about that in a second. This makes me laugh right here because all it says to you basically is to find the intercepts, use the calculator. Okay? There are other ways to find the x-intercepts, and we'll talk about those in just a moment. All right? Now, let's look at these two. Actually, we're not going to look at those two because it's exactly the same problem we did on this worksheet right here. We don't need to overkill. Okay? So let's go ahead and turn the page and look at letter A. Sample problem letter A. Tell me what form it's in first. It is in standard form. How do you know it's in standard form? Because it is not an okay answer. How do you know it's in standard form? ax squared plus bx plus c, right? There's no parentheses or anything like that, okay? So how do I find the vertex in standard form? X-coordinate, I use negative b over 2a, correct? So in this particular problem, what do I need to know? Yeah, a and b, okay? So in this particular problem, what is a? Negative 1, and what's b? b is 6, right? So in this problem, I would have negative 6, because I need negative b, or the opposite of b, right? Times 2, or divided by 2 times a, which is negative 1. Well, what is negative 6 divided by negative 2? 3. So I can start here. I don't know exactly what the other part is, but I know the first part is 3. If I know the first part is 3, what else do I know? Axis of symmetry. Very good. X equals 3. Okay, I'm not even done with the vertex and I already have a whole answer finished, right? Okay, so now how do I finish the vertex though? Yeah, I know. I just need you guys to know. Substitute it in, right? Substitute it in right here. What is 3 squared? Times a negative. Negative 9 plus 18. 9 minus 2. Done. Now at this point, it's really personal preference. I promise I'm not going to be looking to see what order you go in and take off points if it's not my way. You know how I feel about that, right? At this point, it's really personal preference. You can go on to the Y-intercepts, the point symmetric to Y-intercept, and then the X-intercepts. I don't, though. Okay? You guys know I'm a very visual person. I want to see stuff, right? So what I do at this point is I jump over to the table. Where should I put the vertex in the table? Why in the middle? Because it's in the middle of the parabola, isn't it? Okay? The vertex is in the middle of the parabola, so I'm going to go ahead and put that in the middle of my table. Go ahead and fill in my x values. Now at this point, if you want to take the time to plug every number in, that is so great. What else could I do instead? I could use my calculator, right? I could plug this, excuse me, not plug. I could enter this into my graph and look at my table. Isn't it doing exactly the same thing though? Okay, good. What is this, 3? 6? 6, 3, negative 2. Wait. I didn't do any math for these 3 right here. Once I knew the first one, the second one, and the third one, I just filled in the whole table. So am I just being disrespectful or insolent or something like that? Shut up. What do I know about parabolas? They're symmetric, right? So once I know one half, don't I know the other half? Or at least half of the table. Obviously not half of the parabola because it's infinite, but we won't go there right now. Okay? So I'm going to go ahead and graph it. 0, negative 2. 1, 3. 2, 6. 3, 7. 4, 6. 5, 3. And 6, negative 2. Now how easy is it to tell where the y-intercept is? From the graph and from the table, right? 0, negative 2. I'm going to go ahead and draw in my line of symmetry, just in case some of you still need that. What point is symmetric to the y-intercept? What point has the same y value but is on the other side of the axis of symmetry? Six, negative 2. And where are the x-intercepts? Are they easy to see? No. Okay? When they're not easy to see, we have a couple choices. An x-intercept has a y equal to 0. So I could set that equal to 0 and try to solve that. Or I could actually do exactly what it told me to and plug it into the calculator, right? Let me get rid of my table real quick. I'm going to put in negative, not that, negative x squared plus 6x minus 2. Menu. We're analyzing our graph. So number 6. We are finding a 0. Okay? An x-intercept, we haven't gotten there yet, so I'm just trying to tell you about that. An x-intercept is also called a 0. Okay? So I'm going to choose number 1. Now, it's saying lower bound. I need to move this on the left-hand side. Anywhere on the left-hand side of that 0 is fine. I usually try to get it nearby. And then I click my middle button. And then it's saying upper bound. I need to move it on the right-hand side of that 0. And you'll notice as soon as I move it, it pops up, doesn't it? But when I click it, it tells me for sure. Okay? So my first x-intercept is 0.35, 0. Is that it? Any time, will there ever be a time with quadratics that I only have one x-intercept? Ever? If the vertex is on the x-axis, right? And for the record, several of you said it, we are still only talking about functional parabolas. So only opening up or down. Okay, obviously left or right we could have several different things, right? Okay, so good thinking on that. So let me go find the other one real quick. Menu, analyze, a 0. So I want to put it on the left-hand side, and I want to put it on the right-hand side. Click. Okay. So this 0 would be 5.7, 0. Is that what you got? God bless you. Any questions? Okay, so that problem's done. Are there really no questions? Feeling any more confident about finding some of this stuff than when I first showed you this weird table on the front? Yes? Okay, good. Look at B. Tell me what you realize, what you recognize, what you notice. It is not in standard form. It is in vertex form. Okay? So how easy is it to find the vertex? Tell me what the vertex is then. What is it? We're on B, right? X minus h squared plus k. And my vertex is where? HK. So negative 1, 3. Yeah? Okay. Just for kicks and giggles, it doesn't ask for this, but tell me please, is this vertex a minimum or a maximum? Could you tell by looking just at that? Could you tell just by looking at that if it was a minimum or a maximum? How? That negative, it's opening down, right? So that would be a maximum. Okay? What about this one? Is this a minimum or a maximum? How do you know it's a minimum? It's positive, so it's going to be opening up, right? That A value. All right? If we know the vertex, do I also know the axis of symmetry? What is it? What am I doing? X equals negative 1. Okay? Again, this is the point at which you can go your own direction. If you want to go ahead and find the rest of these, that's great. If you want to go and graph it, that's great. If you want to go and find the table, that's great. What am I going to do? I'm going to find the table. Is it wrong if you do something else? Absolutely not. But where's my vertex going to go in the table? In the middle, right? Regardless of what direction you go, when you get to the table, go ahead and put your vertex in the middle. Then I'm going to plot mine I can't graph that one's too far off. Negative 11, positive 11, negative 2, positive 5, negative 1, positive 3, 0, 5, 1, 11. You with me? Pausing. I'm pausing. Alright, so what you got for a y-intercept? 0, 5. Okay. What about a point symmetric to the y-intercept? Are any of you still needing to draw the axis of symmetry? Circle that so you can circle that? God bless you. If you are, please do it. If not, that's fine too. I think that looks like a deer, but that's just me. What about the X-Intercepts? So you're not even going to try to find them? Why not? To have X-Intercepts requires that the graph crosses the x-axis, right? Does this graph cross the x-axis? No, there's not any y-intercepts. If there were, you would know how to find them, right? Okay? You could look and see where it crossed the x-axis, and if it happens to cross at nice points, that's great. Like this one did, right? The one we did, the first worksheet we did, these crossed at really nice points. They even showed up on the table, right? X-intercepts are where y equals 0. They both happen to show up on the table. If not, we can do like we did on this one and use our calculator. Okay? Any questions about these so far? Okay? Before I get going too fast and forget, actually that's it, isn't it? That's only sample problems. Okay, please circle number 1. Number 2. Can I take that back? Okay, please circle 3 and 4, not 1 and 2. Not 1 and 2, but 3 and 4. Please circle 5A, right here. D, E, F, and G. A, D, E, F, and G. Okay? Again, the questions that are not assigned, if you do them, they are extra credit. Keep that in mind. Okay? Any questions? Please come to tutorials and talk to me if you need my help. I'm here. Sometimes there's even other people here that you can talk to, and that's okay. Any more questions? All right. Peace.